base 10 blocks are a great way to model our 4 basic operations of adding, subtracting, multiplying, and dividing. And here I have some nice foam base 10 blocks, but you can find templates online and print a paper version out, or you can just draw pictures. Here I have 3 place values represented. The little square represents my ones place, and I can see that 10 ones can cash in and form this stick that represents my tens place, and 10 tens cash in and represent this big square, which represents my hundreds place. So for this video, I'm not going to use the blocks, I'm just going to draw pictures. So over here, I'm going to subtract 323 minus 157 using base 10 blocks drawn in pictures. So when I draw a square, I'm representing the hundreds place, a stick will be the tens place, and a dot will be the ones place. And I'm going to use the takeaway model. So I'm physically going to put 323 on the table in blocks, and I'm going to physically take away 157. So I have 3 hundreds, 2 tens, and 3 ones on the table. I'm being asked to subtract 100, 5 tens, and 7 ones. So I can see that I only have 3 ones, and I'm being asked to take away 7. I don't have enough, so I'm going to have to regroup. I'm going to come over to this 10 and cash it in. That 10 breaks into 10 ones. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So now I can see that I have 13 ones to work with. So now I have more than enough to take away 7. Now the important thing with base 10 blocks is you always want to connect it back to our algorithm. The base 10 blocks are great as a visual way to understand what's happening in our algorithm, but if we don't connect it back to the algorithm, the students will never wean themselves off the blocks. So what's happened over here? I used to have 2 tens, but I cashed one of them in, so now I'm only left with 1. So of those 2, I borrowed 1, and 1 remains. And that 1 I borrowed cashed in for 10 ones. So you might want to put a little 10 here and then say that 10 plus the 3 we already had gave us 13 now. Or based on the level of understanding of the student, you can just put the little 1 in front to represent 13. But in either case, I have 13 ones, so now I can take away 7. So 1, 2, 3, 4, 5, 6, 7 get taken away, and I can see I'm left with 6 ones on the table. So in my ones column, I have 6 remaining. Now I have 1 10 left, but I'm being asked to take away 5 tens. Don't have enough, so I have to borrow or regroup. So I'm going to cash in this 100, and when I cash them in, I'm going to get 10 tens. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I can see I have 10 tens plus the 1 I already had. That's 11 tens to work with now. And in our algorithm, we started with 3 hundreds, but when we cashed 1 in, that only leaves me 2 left. And that 100 I borrowed cashed in for 10 tens, so now I have 11 tens. So again, you can write a 10 in this column, plus the 1 I already had gave me 11, or based on the level of understanding, you could just put a 1 in front to represent 11. In either case, I now have 11 tens, and I can take 5 away. 1, 2, 3, 4, 5. So there are 1, 2, 3, 4, 5, 6 tens remaining. So in my tens column, I'm going to record 6 remaining. Now I have 2 hundreds. I'm being asked to take away 100. That can be done. Take it away, and there's 100 left.